Hey guys, this is Kris Schermerhorn. We're going to do the part two of working with the acetal, Zirlux Acetal frameworks. So in the first part, we designed the framework, went over that design process, milling, finishing it up. Let's say at that point you send it out for try-in. Doctor says the frame fits great, and now we have to apply acrylic saddles and teeth to it. And so there's several different ways you can go about that, and we're going to review those in this part two. So as you can see here, the way I see it, there's four different ways of completing a framework. One, it's the conventional way. You get the framework back just as you would get a metal frame back from a try-in. And then you would take it, set teeth on there in wax. At that point it could go for another try-in or continued on with investing, processing, and finishing. And that's fine. Did that for many years. I've been doing acetal frames since '97, so that works just fine. But now as we get into the digital age, we're more and more trying to convert and switch over to try to keep everything as digital as possible. And so the second, third, and fourth options give you that. So the second one would be to digitally design the teeth. You would then print or mill them, and then you would set them in place with wax, and then it would go from there and be invested and traditionally packing the pink acrylic flanges and finishing, right? So that's kind of a partially processed digitally. Okay, so you had digitally design your frame, digitally design the teeth, and then you just finish things up with processing your pink acrylic. Lastly, you would, or thirdly, you would have digitally designed teeth and saddle to the frame. And so at that point, you would 3D print or mill your saddles, 3D print or mill your teeth. The teeth would be bonded to the saddle would be bonded to the acetal framework. And so I would say this is 95% digital. The only part that's analog or by hand is kind of bringing everything together. And then lastly, number 4, 100% digitally designed frame and teeth, right? So this is a little bit of a different design of the partial than what we saw in the first part 1 part of that. But I want to show that because that is a 100% digitally designed appliance. So we'll go over those here kind of on the computer. I'll digitally design and kind of show you the workflow using Exocad through each one of these steps. So I'm going to minimize this and bring up my Exocad. And so the first one on the list is simply creating the teeth. And so here's kind of the work order that I've set up. So I'm going to click on these teeth that's already set up, but to show you what I chose. So in this instance, I'm going to choose anatomic pontic. Nice thing about this is you don't have to have partial or denture module added to your Exocad. So if you had the basic crown bridge, you can create the anatomic pontic. And that's it, right? So anatomic pontic, I choose. And so each one of these teeth are chosen as an anatomic pontic. I do like to splint them together. You don't have to, but choosing the green dot will allow, tells the computer that you want them splinted. I then choose my adjacent. Material wise in there, you choose either printed or milled. Doesn't make too much of a difference. A lot of the settings are similar. And we hit save. So I'm not having an opposing in this one. It kind of naturally gives you an opposing, but I'm not on this just for simplicity's sake for this. And then we hit design. So when I set these teeth in place, I'm not going to go crazy with making everything perfect just so I don't take up too much of your time. You'll get the gist of kind of how the workflow is, and you'll be able to do that. So with the this case in particular, I've designed the frame and I have the model, and so what I've done is brought up the model and the frame that I designed, and I've saved them as an STL. So you can see here the framework is on the model and one thing. All right, so the computer believes that this is just the model. That's the bottom of the model, which is the frame. And so to do that, all you do, if this was a framework, this would be green in my software, and then the model would be the model color. What I'm going to do is save scene here. I would go here and save, it's asking how I want to save. I want to save as an STL, and then I would name this whatever I want to name it, and then hit save. And I could save it to my desktop, I could save it in the actual case, and what it's going to do is take the framework, anything that it sees or that you've left showing on the screen, it'll save as an STL, and then you can import it in. I find that's the best way. You could design the frame and then kind of continue on. It can get a little, not really glitchy on you, but it kind of asks for things that you don't really need to ask for. It's difficult for it to kind of create a virtual bottom, which you'll see in a little bit. So I just do it this way, and seems to be, works well. It's asking you to line up, so I just like to look down on the model and make sure I'm looking at it pretty parallel. We're not doing clasps at this point, so we have no real path of insertion. We just want to create the teeth. It's asking you to mirror. If you had some anteriors and you want them to look the same, you could do that, but in this case we're just creating the bottom. So here it's showing asking a question. So in our setup we kind of didn't really mark any of this stuff, but it kind of this is a second check to see, no, we're not going to create any gingival design, we're just creating the teeth. So we'll leave it on that and continue forward. So here it's going to ask for us to place the teeth. You're simply going to click, drag across the other side and click. This is not, and then here you could choose between different molds. We'll just keep this kind of simple. But this is not by any means exactly where the teeth will be. This is kind of just generally getting them in place. All right, so once we get them generally in place, again, they're a little big, we can correct all that. Go to next. This will bring you into kind of your tooth placement and gives you this chain mode, and so you can kind of move these around. You can make them smaller, bigger. So that initial is literally just something to get the teeth in there, allow you to choose maybe a different mold, some things like that. And so we can click on these and move the whole thing here. This isn't necessarily a tutorial on exocad, but that's chain mode. You can lock, like let's say this molar's a little big, but the rest of the teeth are a good size. I can lock that in and just move that individual tooth. Things like that. I can move to simple. Now simple kind of can do the same thing. I can move this guy around. I can kind of give him a little twist individually. Things like that are able to be done here. These teeth seem to be leaning a little bit, so I'm going to tilt them in. Some things like that. Again, I'm not going to get crazy into this. Go to next once you feel like you got your teeth in a generally good spot. Here you can go in, you can move your cusps. All right, you can go and move kind of a bigger area. You could go kind of move your entire tooth except for your base, and then ridges are good for, like, you want to make this kind of interproximal a little deeper. It kind of moves these small little areas like that. You can also go to your free, and you have add and remove. It's simple. Wherever this circle is, it'll just add to it. You can see there. You can always hit your undo button. Smoothing, it'll just kind of smooth out. If I hit shift and smooth, it'll take a lot off, kind of makes it flat almost. Same thing with the add remove. As much as I was able to add, I can hit my shift button and do the same thing, and it actually takes away. And so you could add a little here, make these a little pointy. You could kind of take those, and then let's hit the smoothing, and I'm just going to round them. So things like that you can do to really customize. A lot of times with these, when I have these clasps here, is I'll go to tooth parts, and I'll kind of drag and go over top and kind of add some to kind of cap over that, because it's going to adapt to it, so we can kind of make it ideal. In a little bit it's going to ask for connectors, and I'll kind of add in here, kind of bulk this interproximal up, and then I'll show you kind of why here in a second, but we'll add that, and then we'll leave this one with a little bit more of a gap there. Alright, so then we would go to adapt. Alright, and so with adapt, first it's going to ask you to adapt to Pontic. I'll leave that at 0 and adapt. And so what it's going to do is all this tooth structure poking through the bottom, it's going to adapt that so that it's sitting flush to the model. And in this case, the model is also the framework. So it'll kind of sit to that meshwork, which is handy whenever you are done milling or printing these, because these little retentive holes and stuff will give you a reference point. So this will sit right down into the spot, and then you'll know exactly where it was digitally, and then you can take it and add your wax and kind of fill everything in. But here I'm going to take away my model, and you can kind of see how things kind of come out. Now what I like to do here is I'll hit free, hit smooth, kind of make my tool big, and I'll hit the shift key, and I'll kind of go around all this, and I'm just going to soften all these kind of sharp edges. I'll bring in my model. I'll look at my adjacent teeth and say, well, I'm hanging way low. Of course, the acrylic will kind of cover that, but this will make it easier on my milling machine if I'm milling it to have some softer angles. It'll make it easier on even the printer. I mean, the printer won't have too much of an issue with it, but you can kind of smooth that. But I will go back and I'll go ahead and adapt again. And so all those holes that are kind of going down, and I'll make them just a little less aggressive down in there, so that we have a more likelihood of it fitting into place and not binding and not filling in an area, and then you set it on there and you think it's all the way down, but it's not. And hopefully if you have it articulated, you'll have a second check on that. But this just kind of makes things a little softer and a little smoother. Next we'll go to our interproximal. Okay. Now sometimes the software have a little bit of a difficulty differentiating the bottom from the interproximal. It did a pretty good job here, but you can see we have a little bit of a crease there. All right, and you can see that's poking through, because it's kind of like, I don't know, I'm adapting the bottom, I'm adapting the top. This is a little no man's land. So I'm going to go in here, go to smooth, I'm going to hit that smoothing, and just kind of take that away with the smoothing, and that'll make everything nice. All right. All right, and then simply that's it. Oh, well, it's going to ask us for our supports, so or our connectors. So it's going to give you a choice of connectors. It's going to give you this one as a default. You can move it around, and in this case, that's fine, or it's not fine. That's up to you. You have these little bumps will probably be covered with acrylic. But one thing you can do is go to this plus sign, and this plus sign is going to only put the connector, I just hit apply, to where the teeth are making contact with themselves. So you can see here where I added the one connector and I made it broad, it made a nice big connector. Here where it has a gap, it made for a smaller connector, which probably would be fine. You're going to be investing in acrylic, but sometimes you pop it off the build plate and it may snap there or something. So I'll add just to kind of fill that in. So that's up to you. You know, again, some of you might choose to kind of do them separately, and that's okay. And that's it. So what this is going to do now is save those teeth. And you'll take those and print those and bring them over to your case and process. So the next way to do it is to do do the teeth and the flange. And so I'm going to set up that, we'll call it teeth and flange. And we're going to mark our teeth just as we did before, but we're going to do partial denture. All right, and here we'll choose 3D printing. There's nothing here to really change. And I'm going to drag and drop to each tooth that's going to be involved in the process, as well as mark the teeth as adjacents. And I'm not going to mark any opposing. And then we'll save and then design. And so really the difference here is we were telling in anatomic pontics, this is an instance where you would need to have the teeth, you would have to have the partial module and or partial and denture module. Or you could just have the denture module, I think. I'd have to look into that. But it does give you some of those options. So we're going to choose the same, right? So we're going to have the frame with the model. All right, and we're going to go through a lot of the same thing. We're going to kind of look down upon it, not crucial, but just generally look down, and that's going to be the path of insertion of what all we do. It's not crucial. We're not doing any mirroring or copying. It's the same thing, everything you saw. All right, we'll go next. I'm not going to take a ton of time because we already kind of went over the setting up of this. So they're looking a little big, so we'll bring them down. And again, these could be more ideal, but we're not going to go crazy and waste time doing that. And so here we could fine-tune things, but we're not really going to mess with it. But when I adapt this time, I'm going to go ahead and create some space, at least a 0.5 millimeter between the teeth and what in this case would be the partial. And so same thing as before, but where we adapted directly to, at 0 basically, right to the model, which is also the frame, I'm adapting to the to that same thing, but with a gap created between them of about 0.6. You know, I would say you want to be, I would say 0.6 to 1 millimeter of gap, just enough so that you can kind of have a little space. And so same thing that I did before. Once I adapt, I'm going to go ahead and go back to my freeforming, hit smoothing. I'm going to make my tool big. I hit shift and roll, and then I'm going to smooth. I'm going to hold the shift key, and it's going to kind of smooth everything out and take some of that sharp angles away. And I'm doing right now without the shift, so it's going to kind of not really remove much material, but it's going to smooth what's there. And then I'm going to go in here, my settings are still there, and I'm going to adapt again. And that should make it easy on the mill or and or the printer, depending on what you would like to use to produce these. Once we adapt the underside or the pontic to the frame with a little bit of space, we will then go to the interproximal, adapt as well, and things look pretty good here. Same thing, not quite as bad. But you can see it's just a little confused. We'll just kind of smooth that away. Let's check the other side. Looks good. Alright. So then we go to next. Now, at this point it's going to ask you, hey, do you want to make a framework? And this means it's going to take you to the partial module and you do a framework of finish lines and a typical framework. And this is kind of nice. You can kind of take this information and, if you were to want to make a framework with the finish line adapted really nicely to the linguals of the teeth that you're going to use, you could do that at this point. That would work perfectly fine. But we're going to do saddles and we want sockets and all that. So this is a little misleading, but it's design over denture gingiva. So we're not doing a denture. I mean, we're doing a partial one, but that's what you want to choose. And so now we're going to move on to the denture module essentially, but it's actually going to be a partial in this part. So here it's going to ask for your path of insertion again. Again, we aren't doing any clasps, so no real issue with the path of insertion. So we're fine. But if you did want to move it, that's showing you the undercut. If you wanted to be like, oh, I want to tilt it a little that way, you just hit set to direction and it would adjust that. Here we're going to be creating our virtual bottom or the model, and there's a couple settings in here and I like them all. Right, there's a bit of an offset that makes up for just a little discrepancies, but it seems to have a really good fit and result. Smoothing, it's going to take all the sharp angles and smooth them out 17%. I find that to be a good number. And then milling diameter. So if you're going to print, don't worry about it. If you are printing, milling, 1.2 is good if you're going to be finishing with like a 0.8, even a 0.6 millimeter tool. Having a little bit more leeway is better than not. So in other words, if you're milling with a 0.6 millimeter tool, you don't want to move this to 0.6. You want to make it just a little bigger so that it kind of rounds off, and any area that was really sharp and fine, it'll make that more rounder so that this 1.2 millimeter tool could fit, even though you're using a smaller one. And so I've just found that this 1.2 is good if you are going to be milling. We're going to be printing or supposedly printing, so we'll take that off. And then this one here, you can block out at an angle. I usually leave this at a 0, and I actually will take undercuts and put them at 0 because I'm going to kind of expose the undercuts on my own. And whether I'm doing it like this or if I was doing clasps. So I'll put that at 0, and then I'm going to hit apply. And so once we hit apply, it's taking all this information and creating a virtual bottom. And you'll see once this is accepted and kind of works through, that a lot of the sharpness that we see here around these retentive holes and things will be smoothed and be rounded. And that's just good. I mean, we're going to be bonding things together. So you want almost space to allow for your resin that you're or material that you're going to use to bond everything together. You don't want things fitting so precise. It's just like a crown, a die spacer. You want to have just a little bit of a gap to make space for the resin that you'll use to attach everything. Okay, and so here's what I was talking about. You can see things are all smoothed and a little bit more rounded. Right, and that's our virtual model. So if you're happy with that, that's good. So let's say a little bit of undercut here that I'm worried about. So you can hit freeforming, and then you come in here and you can actually take away the block out that's happened. All right. You know, oh, maybe there you want it to fit, you know, whatever it is, but you can take that away. Or let's say you're like, man, I want more block out there. So I was add remove, I was hitting shift to take away. Now I'm going to let go and not hit shift, and we can actually add it. So you can manipulate this under the free form however you want. You could even smooth things some more. Like let's say this finish line, sometimes I'll come in here and the finish line it'll kind of round, but I want that to be a little more crisp. So I'll come in here and I'll take away the smoothing or kind of the block out that's been created there and make that a little bit more crisp. So things like that can be done. So once we go there, now it says, okay, here's back your teeth that you designed, and we're ready to do the gingiva. Now it's asking, do you want to make a single combined gingiva for each piece? All right, so somehow, you know, like let's say we're actually doing like a Duraflex partial, and we did 2 separate sets of teeth. We want to make it one big partial. That's what you would choose. But here, no, we want to design separate gingival parts for each bridge or set of teeth. So first it's going to bring us over here. It's going to give us our thicknesses. I usually put it about 2 millimeter thickness, and we can change that. And I'm going to go along and mark my borders. Again, I'm not going to get super precise with things. Double click once I'm there, and this doesn't mean you're done, right? So I'll kind of usually click and just got to get a general. You see that's a little pointed out. That's fine. What it's going to do is accept this, kind of give me a view of it here, and then I can go in. I can say, let me pull that in. This is a little long here. You know, whatever you might want to see. I do like just a little bit of an overhang to my finish line. All right, and so we can hit apply, and then it'll show me what my changes did. And again, this is kind of just setting your base. This isn't what it's going to final look like. So that all looks good to me. So I'm going to go to next. And take me over to the other set of teeth. Same thing. I'll just go along. Again, we'll expand over and give us a little bit of a kind of lock into that hamular notch area. Double click, and now it's going to again create this, and let me take a look and see if it's everything that I want. And I forgot to do the 2 millimeter, and that's fine because we're still checking over things. And I'm going to probably make some changes and apply again, and it'll apply once I make those changes. So it's not a big deal. Probably overextended there a little bit, so we'll see how it looks once it accepts it. Okay, so I'm going to change that to 2 millimeters. Yeah, I think I'm just a little overextended there. Everything else looks pretty good, so I'm going to go ahead and hit apply, and that'll make it thicker. And then also that little bit of a change that I made over here. You know, it's interesting, the denture module, once you create your outline and you double click, it doesn't adapt it or make it yet. You can go in and change and move and everything, but for the partial module it does. And you know, I don't know if I like it or dislike it. It's neither here nor there. We're going to go to next. Now it's going to allow us to manipulate this and kind of fine tune it. So we have small regions, right? We can pull, kind of fill up these interproximals that it didn't quite fill. You have a huge region, so we can kind of bulk out some areas and it'll pull a larger amount out. So I'll kind of go in here, same thing on this side. I'm going to pull it from the lingual. And the buccal. I'm going to go to the large because it's fussing with me a teeny bit there. Alright, and then we can go to free. same thing, add remove. So if you want to go a little higher on the lingual of this, we're just hitting the add. There's a little step there. Let's add that. Kind of go around this tooth. And then we can come back with the smooth. I'm not hitting the shift key, just smooth, and we'll smooth some of this out. And again, we're not going to go crazy here with this design, but let's fill that in just a bit and kind of get you to where you need to be. And then when we hit next, it's going to ask for our supports. I'm going to go ahead and hit the plus, which means that I'm just going to make wherever I'm making contact. It's going to give me just a little support there. You can see here, and that's fine for this. Again, the only thing I'll see sometimes is once it comes out of print, it may snap on me or something, but that's somewhat rare. All right, so it has your tooth gaps, right? So I want 0.5 underneath the teeth. I've already set it to 0.6, so it should be fine for that, but it'll adapt anything that might not quite be there. The gap in the socket, 0.08, that's fine. That gives us a little gap for our resin. I don't want to do any angle. I do want to block out the tooth pockets. So being that these are all splinted, they all have different angles to them, the software will kind of make sure if there's any path of insertion issue, it'll block it out. Consider tool diameter. If you are milling, then I would put this at 1.2. If you're kind of using a 0.6 or 0.8 finishing tool, but I'm printing, so I'm taking that away. And then smooth the basal area, I'll put that at 20%. It'll kind of just smooth things out a little bit. All right, so now we're adapting. So the software is going to be working to not only adapt the teeth and create sockets, but it's going to adapt away all of this to the ridge. So it's going to start to create sockets here, and then like we're seeing up top, and then it's going to adapt the underside to the model, which is also the partial. Now, if you get errors at this point, which can happen now and again, it'll have something it just doesn't like. The first thing you want to do is visually see if all the teeth sockets become created before the error happens. If that's the case, then everything on the top side, as far as the teeth relating to the saddles, is good. So here, what I'm seeing here is okay. Everything is good from the bottom of the teeth to the sockets. If I had gotten an error after that, and there was still the pink showing through, then it would have a problem with how things relate from the bottom of your saddle to the model. And in that case, usually I'll go up in and I'll smooth the bottom of the what's there, that blob that kind of pokes down through. I'll take away my model and I would smooth all that and make sure I don't have any overhangs over the border of the model, some things like that to try to get it to go through. But in this case, everything went through. You can see how it's adapted to that. So whenever you print these bases and you print the teeth should sit down in here and you should be able to bond them together, and then this piece will bond to the framework. With this instance, you could use a resin, but it's tricky because all the resins we have, like let's say you printed this out of Trusana, the Trusana resins is pretty flowable and a little hard to manage and a little hard to keep from sticking to even a stone model. So that can be a challenge. You could bond the teeth into the sockets with like Dentsupply's Lucitone Fuse. Also, Trusana, Meyerson will be releasing the Trusana denture base along with its bonding agent, so you could use that bonding agent to bond the teeth to the base, because there's not much volume of material. On the underside here, there's some worry of it flowing everywhere. So you may just use acrylic. What I will do is get a fiberless acrylic, it doesn't have any of the fiber veins in it, or I'll just filter the veins out of the acrylic, and that'll kind of match. And like with Trusana, you get a really nice bond as long as you treat the surface, roughen it a bit, maybe give it a dusting from a sandblaster, aluminum oxide, or scuff everything up, and then really treat it with monomer. Or if you have any treatment that you use to treat denture teeth before you pack to them, a lot of those are just like harsh kind of monomers to really kind of break down that surface. But the acrylic will bond to it really nicely. But you guys, depending on the materials you use, I mean, if you mill it, it's acrylic, just use acrylic and you can bond everything together. All right, and so that's everything there. All right, and so lastly, we're actually going to keep the same setup we have here. All right, so I am going to click New. I'm going to call this All-acetyl. And we will mark this as a denture. We're definitely going to be milling this because it's all acetal. And then I'm going to mark each tooth. We'll mark our adjacent teeth. No opposing. And we'll hit save. And then we'll hit design. And this time, really the difference will be the model that I import in, because we're going to be creating the frame and the teeth. And so if there's no file in amongst, it automatically asks for a frame. So I went upper model only. So this is the same model, just doesn't have the framework on it. All right, so now a little more important, I want to get my path of insertion together because I am going to be creating clasps. All right, so I just kind of want to look down. Again, there's another part of this software we'll be doing this, but this will get you close to there. And so it's smart to do it now. Again, we aren't going to copy or mirror. So same thing, I'm going to zip through this real quick because you guys have already seen it a couple of times. Nice thing is these workflows are all somewhat similar to each other. So it's no matter what you're doing, once you teach someone or once you start to do a couple, you'll feel very comfortable, switching in between them. All right, again, I'm not going to spend a ton of time just because I'm not here to teach you Exocad necessarily. I'm just here to show you this workflow. I'm sure you guys would design these differently than I am. All right, so we'll say that's good. We'll go to next. I'm not really going to get in there and adapt them nicely, but what I do is same thing with the Pontic. I'm going to go to 0.6, adapt. Again, you'll see at a later point in this, it'll actually, like before it showed you that you wanted to adapt 0.5 from the ridge. I like to do this because I'm able to take away the sharp angles better. That will so that will keep things from just milling nicely, especially if you're going to create sockets. We aren't in this case, but if you're creating sockets, that will make the less sharp angles, just makes everything fit a little bit nicer. So on this one, everything you see, pay attention to. At the end, I'll show you two different ways of kind of doing this, especially if you don't have the partial or denture module with this. So we'll also adapt our interproximals, and then we will move on. So in this case, let me go back. In this case, we're creating, we could either create this as one piece or two pieces. So if you were creating two pieces, I would ask you to reference my Duraflex videos that are on Zahn's YouTube channel, and show you how to use the attachment tool to hit subtract. I'll show you real quick. Hit generic and hit cutout, and it gives you a tube. And then you can go in here and make a hole like that, because you're going to want to mechanically bond these. So you could do an acetal, milled pink acetal base, and then you could do acetal teeth or any teeth in this instance. But I'm going to show you also, really the main thrust is going to be to do a monolithic, and so I'll kind of show you, you know, that's the main thrust, but that is a way you could do it. There's kind of multiple ways. Same thing here, we're going to go to the gingival. So it says denture, but it's not. All right, just like when we had our frame, now we're going to do clasps, so it's a little bit more particular, right? So I'm showing good undercut here, decent there. This all looks actually pretty good for my path of insertion, so I'm going to leave that. Again, all these properties are going to stay, so I'm going to hit apply, and it's going to create my virtual bottom. So while this is loading, one thing that we could have done here too is chose anatomic pontic like we did in the very first one, and then chose to do a virtual gingiva. So if you don't have the partial denture module or the denture module, what you would do is go in here and you would choose anatomic pontic, and here virtual gingiva, you would choose that. Virtual gingiva is like, hey, you're doing like an all on X case, right? But you're not, so you're tricking the software a little bit, but it won't let you separate the teeth from the base, which is fine because that's kind of what I'm showing. So that'd be great for like little Nesbits or really anything, as long as you were willing to have clasps, teeth, base, all tooth colored. And then you could go in with like OptiGlaze and do some coloring, you know, to that. So that's a way that you could go through the same exact process that we're doing now, if you don't have the partial denture module, right? So here it's showing some undercut. I'm going to go to freeform. I'm going to hit shift, and I'm going to take away. I'm expose a little bit towards the tip. It's a flexible material, so it's going to be able to engage much more undercut than you could with metal, right? This partial is going to cease to be flexible in the interproximal, so I want to take away any undercut there. All right, the clasps can put up with a lot of flex, but in the interproximal, it will not. All right, and we will take that away. All right, and then we go to next. There's our teeth. It's saying, do you want to do one or two? In this case, we want to do one single unit because we're doing the whole partial. All right, this is a good thickness for acetal. Acetal can be pretty thin. So I'm going to go ahead and mark my major connector. Let me do a little bit of a strap here just to change things up from the way our acetal was. And then we're going to do a clasp. Now, the base is going to be tooth colored, so the clasp needs to stay up on the tooth. You can lap onto the gingiva ever so slightly. It's not going to be the end of the world, but And I'm just going to go across again. I'm not going to spend an awful amount of time because once I accept, I can go back and make finer changes. And if you wanted to butt the teeth to the gum, you could do that, being that I'm going to show you guys something here. You know, that you're going to be doing maybe an all tooth colored one. I'll do that on this side and show you once this is accepted. And so on this side, I'll take and just, again, if you guys haven't used OptiGlaze, it's a nice material to kind of play around with the acetals. You know, how long is it going to last? It's a thin painted on coating. You definitely only want to put it on areas that are thick. You know, the thinner areas that have flex, like a clasp, they'll flex. The OptiGlaze really won't. It'll wind up crackling and delaminating. So I would definitely put it on only thick areas, and even you know, as more of a long-term temporary kind of option. So I'm just going to take this and kind of let that scallop around the base of the teeth a little bit, so we don't have much flange that's tooth colored that would need an OptiGlaze. Alright, we'll save that. I'll leave this side normal, and I'll show you what I'm doing here, being that I'm kind of capping over the tooth. And even if you mark your spline, 3Shape kind of holds you to your spline that you create. With Exocad, you can really manipulate it however you want. It's not something that's held locked in stone. Part of your design is that spline, because I can see I have like a little dip and I'm going a little bit angle, but I can correct that after the fact. So it's up to you. You could either move the spline and go through this waiting process of it kind of designing everything, or you can go ahead and accept it and go past, and then I'll show you guys how you can kind of manipulate that after the fact. Alright, everything looks good. We'll move on to next. So now again, just like before, we can fine tune. So what I can do to let's say I like this side, but this side over here I want to change it. I'll go to my freeform, I'll go to add remove. I'm going to take away my desired thickness and my bottom boundary, and so now it'll let me take that all away, and so now I can make that look the same. If I keep my bottom boundary, it would limit me on that. So you can definitely put it back once you make adjustments like that, because it'll allow you to go thinner than you realize, and you could wind up thinning things down way more than you were thinking, and until you actually wind up milling it or printing it and then getting it in your hands and going, oh, this is too thin. Keeping your bottom boundary on will help you to not have that happen. So here all I'm doing is just kind of adapting things and smoothing things. I'm not going to go crazy. I could definitely spend an extra 5 minutes and make things look better, but that doesn't really, it just wastes your time. So I am going to fill this. All right. All right, this all is looking pretty good. Let's smooth this. One thing that I'll do with clasps is I'll go in here to the smooth. I'm not touching anything, just towards the tip, and I'll just hit the smoothing button, and it'll just kind of thin that point down. It just saves you a little bit finishing. All right, this guy here. So what I'm going to do is I'm going to go in and I'm going to take off my bottom boundary so I can actually make it thin. And then what I'm going to do is just hit my remove button and go right through. So I'm going to do more of like a circular ring clasp on this back tooth. So there's no real option for creating that. All right, so when I hit my remove, it's actually adding, because what it's done is I've thinned through kind of the top layer, and now I'm in the bottom layer, so where it thinks that I'm taking away, I'm actually adding. But all you have to do is go under here and just hit the add button, right? And now I'm going to give the software something to work with down in this channel, because it's it's as a workaround. It's not expecting this, so I'm just going to add, and you can add as much as you want here. I will go back and smooth it out a little bit, and then now that'll give me something to work with, so now it won't happen. I can take away because I have room, because I kind of punched through and got to the bottom side, because it kind of, the software has like a bottom and a top. You know, what you see here is the top, and what you see here is the bottom, and all the stuff in between you can kind of manipulate, but once you get close to the other, then it'll give you hiccups like we just saw there. All right, and so that's kind of our little ring. So next, at this point, we'll take our plus, that's fine, it's just saying it didn't like something, but probably because some things were a little thin. All right, so all this is good. Block out undercuts, yes. Consider tool diameter. So if you're milling it, yes. If you're not, no. And then you'll hit apply. So same thing as we saw before, except for we're kind of doing the whole partial. Again, you'd have your pink acetal or tooth colored acetal base, and then the teeth could be whatever you kind of want them to be. If you had done the anatomic pontic with virtual gingiva, at this point the software would make both the teeth and the base the same, and so you'd have to do them in tooth color, because you have to have the teeth in tooth color, and then you could optiglaze the base. So where this is working to create sockets in between, you know, that is what it's working at now. With the pontic virtual anatomic pontic virtual gingiva, it would be making it all one thing here, and you'd want your mechanical retentions again to keep the teeth into place. That post that I showed you, you'd want to do that to each tooth and make sure you have mechanical properties. I think you could also wonder if it'll allow you. All right, and so there's our case. And again, you'd have to have mechanical posts up in there, to, you know, with that. And then, I wonder, let me check one thing as I'm thinking here. Yeah, so that's everything. And again, at this point, and one thing you could do too, like if you kind of went through this and were like, man, better if this thing was one piece. You know, you get so far, you could hit this, save as STL, click this, STL, say mono, and it'll save wherever you want. But if it saves directly to this case, do you want to only visible? Yes. This is like, if you're going to move it to different ones, you can use the original coordination, which means how this was scanned in, or how this will save it in that orientation, or when we changed everything for path of insertion, you can save for that. In this instance, it really doesn't matter, so whichever. And then if you go back into your case here, and so then it'll save your case, and then you can take it and I'll show you kind of what you'll end up with. Okay. Oh. Right. And except 'cause I changed that one tooth. And so here's our mono. All right, and so you'd have this to do as one piece, or you'd have your prosthetic base with sockets, and then the other files would be your teeth. So you got a couple options there. All right, and so when it comes to printing materials, as far as teeth would be concerned in this, I love the Trusana. It's a material that's very resistant, 3D printed, that you can bring in with the acetal. We're going to have the denture base released in this summer, along with the bonding agent with it. We've had the teeth released now for like a year and a half, 2 years, and it's moving along really well. And so yeah, there's just so many options other than just dentures with a lot of these 3D printed materials, as you can we see in how we went over. You could do this, we showed it with the acetal resin, but of course if it's just a metal frame, you could do the saddles and the teeth. And it really depends. Some people may look at that and go, man, I can do it way faster just doing it the traditional way. Very well. It's just so much easier to train somebody to digitally set up teeth than it is to do it by hand with wax and grinding teeth and everything. So what may not make sense to one person could make excellent sense to another. So that's kind of why we want to make everyone aware of it. You can do all, the all-acetal in little unilaterals or Nesbids in lieu of flippers, and they work really, really nice. The acetal is fairly monochromatic, so I wouldn't do one for a central, but definitely a posterior tooth. It's nice because it's all it's all one piece of material, so no joints between materials, very strong. Same thing here, as you can see. These were actually denture teeth that were bonded to the base. So aesthetically in the anterior, that makes sense better than doing it all acetal, just because, again, it's monochromatic and not as aesthetic. It doesn't have the depth of color and then sizal translucency that you'll get with a denture tooth. And then don't forget, we talked about frameworks, but you can do bite splints or night guards with the acetal resin. You can do long-term temporaries on the fixed side. Very strong, very resistant to wear, and very resistant to absorption of moisture. So for a temporary that needs to be in for an extended period of time, it's a great choice. I want to thank you guys for spending the time listening to me.